Hello everyone, and thank you for joining us today for HashiCorp VirtualDays. My name is Peter Murphy and I work at HashiCorp. I'm based in Sydney. I'm excited for today because this webinar actually started out as an Asia Pacific event, but has become a truly global event with over 1,500 people now registered from over 40 countries. So very exciting, and thanks again for everyone for joining. I first want to note that this session is being recorded and a link to the recording will be sent out to everyone who registered after post-processing. I'd also like to take this opportunity to acknowledge our sponsors of HashiDays Sydney, which was due to run today, and we are hoping to reschedule later in the year. So today we're going to talk about how HashiCorp can help you to automate and accelerate your cloud migration journey securely across dynamic infrastructure. We're going to kick things off with HashiCorp Founder and co-CTO Mitchell Hashimoto talking about the remote culture we have here at HashiCorp. Some of us, or a lot of us, are working from home for the first time, and we're still adjusting to this new normal. And HashiCorp has actually been a remote first company since its inception, and Mitchell himself works from home every day. So we thought it'd be good to first hear from him on what he's learned over the years from scaling HashiCorp as a remote first company to nearly 1,000 employees we have today. And after that, we'll go into some technical talks about our core products. But for now, please help me welcome our opening keynote for today, HashiCorp Founder and co-CTO, Mitchell Hashimoto. So over to you, Mitchell.
All right. Hello, everyone. Let me get my screen up here. And perfect. All right. Well, I wish I could be in Australia right now. That sounds a lot better than my home office here, but it's interesting times. And I think because of that, I wanted to share a little bit about how HashiCorp has been sort of a remote first company since the beginning. So I will put a disclaimer that I think a lot of us understand that, the current work from home is not typical remote, but I do think that a lot of this carries over to the way people are working today. And so I kind of wanted to share a bit about that journey and some of the big lessons that we've learned. So this is only, 10 to 15 minutes. So I could probably talk about this for well over an hour. I have before. So I'm going to just highlight some of the big stuff that we've learned. So HashiCorp was founded remote first. There wasn't really a transition to remote at any time, although we didn't plan on it being a thing. It was just sort of how I was used to working, since we were coming from an open source culture and working through GitHub and things like that. But it's not always well known that we were founded remote. So when we founded the company, I had just moved to Los Angeles. Armand was still in San Francisco. And the first hires that we had, almost in order here, were New York City, Chicago, Pittsburgh, and then Columbus, Missouri. And so, you could see that in the first 6 employees here, we were already remote, and we didn't really plan that. It just, happened to be that way since we were hiring our contributors for our projects. And I had never worked for a remote company before, so this led to a lot of learning. We had advisors, things like that, and now it's been almost 8 years since then, and we're still remote first today. So going from those first 6 remote employees to today having well over 900, almost 1,000 employees. And while we do have an office in San Francisco, our process and our culture and the way we work is still very much remote first. And out of those 900 employees, in a typical non-COVID environment, over 800 are working from home. So it's very much the majority of the company that works from home. So everything is remote first. And I think, when I first describe to people that I work from home, whether they're in tech or not, I think the expectation is that it's just like working in an office, except that your office happens to be a room in your house or a desk somewhere in your house. And I think that's not the right mentality to go at it with, because there's fundamentally some pretty big differences from working from home. And I like to say that they work for some people and they don't work for others, and that's okay. So the things I want to cover today are sort of what I view as the 2 major categories of remote first cultures and work from home sort of environments. And The first one is the importance of communication, or how we share ideas and socialize with people. This is really, communication is really the culture of the company, because that's all you really have in a remote environment, is the way you communicate. You don't have in-person activities. You don't have after hours, go to a restaurant or go to a bar or anything. So your culture is effectively purely defined by the way you communicate. And then the second one is just personal health, of how you could be the healthiest and happiest working from home. Because I think a lot of people, again, just think of it like, oh, I've been successful in an office, so working from home, I'll be just as successful. But if you don't, pay close attention to some things that could catch up with you. So I'll start by talking a bit about communication and how we do that at HashiCorp. So the first sort of teaching that we talk through with everyone joining, being remote first, is the importance of recognizing lost social cues. So there isn't body language or facial expressions or just subtle physical movements to really explain what you mean. In a lot of cases with Slack, for example, you don't even have intonations like you're getting through Zoom right now. So it's very hard to know when someone says something, if it's a joke, or if they're angry, or if they're just having a bad day, and they're not, you can't tell that they're trying really hard, but they're just not having a good day. It's difficult. So the solution is to over communicate. And this is challenging for some people because it sometimes feels inefficient, but you realize really quickly that it's more efficient, because people will really understand what you mean really quickly. There won't be any games being played here. And so, really clearly articulate not just what you're saying, but how you're saying it, the emotion behind it. I think the most important and easiest way to do that is through emoji. A lot of people view emoji often as a toy, or as an entertainment device, but emoji for us in our company, for HashiCorp, is a critical communication tool, because sort of as it's almost in the name, right? It conveys emotion through text. So you could say something and put a happy face next to it, and that means something very different than if you put a sad face or a confused face next to something. It's the way that you recreate facial expressions and body language and things like that. The other way is, and I use a mix of both, is to be very explicit, be very careful with tools, language tools like sarcasm and intonations and things like that. The way I do this, the way I recommend others to do this, is don't be subtle. Just put your emotion straight up in a parens, next to what you're saying. So early on in the company, I've gotten in trouble before by making some jokes and not making it clear they were jokes, and some people didn't realize that, and ended up hurting some people's feelings that way. So now I'm just really careful, overly careful, that I'll always put joke or kidding or laughing or some emotion in a parentheses next to it. And when you get started, like I said, this feels weird. It feels like you shouldn't have to do this. You're not used to it. When you're talking, you would never ever say something like this, but it really helps people understand what's going on. And given that over communication, the other thing that's really important is just having a written culture. So remote is one thing, and the thing that usually comes with working remote is usually flexible schedules or time zone differences and things like that. It doesn't have to be that way. Technically, you could have everyone remote in one city and be on the same time zone, but usually once you start doing remote, you start hiring people in different places, and so there's sort of a high correlation between the two. And because of that, being able to write everything down and share knowledge is really important, because real-time discussions, synchronous discussions like Zoom and Slack assume what I call this privilege of presence. It assumes that the person on the receiving end has the privilege of being there, whether physically on the call, or even mentally. Sometimes I'm an engineer. Sometimes I'm in the zone, engineering, programming, working on something, and I turn off my notifications. And if someone's trying to ping me on Slack and they're having a discussion without me, I might just be focusing my attention somewhere else, and I got left out. And so I always say Slack and Zoom assume this privilege, and so they're great places to have discussions, but you really want to use something asynchronous to have approvals and understand that things like email, or there's other forms too, but we use email, is the most inclusive way to get approval. So there's a lot, we use Slack every day, we use Zoom every day, but really the place where decisions happen, where the final approvals happen for us, is email, because you could send something, give somebody the time they need to pay attention to it, to read it, and to respond. And it's, if you build a whole culture around this happens pretty quickly. So every engineering change that happens in the company, for example, goes through an email approval process. And that could be as quick as less than a day to get through the whole thing. And so, if you create this culture of this expectation, then you could plan for it and work around it. So for example, even with my schedule, which could get pretty busy sometimes, I actually carve out 2 hours a week, one hour in the morning for 2 days, to just read the emails that I should be reviewing, right? It's not to just go through emails specifically to read the things that require approval. And I just set that aside, sit in the morning, and usually use an iPad and read through that. And I could schedule that because that's a planned thing that happens in our company. So for us, we use Google Docs for most of our writing, distributed via email. We use Zoom and Slack all the time, but it's really a lot more for discussion and for sort of cultural aspects, meeting people, things like that. But writing is probably, in my opinion, the #1 skill to be successful at our company. And from what I've heard from others, the #1 skill to be successful at any remote company. You have to be able to write really well. There's this other concept that I sort of hinted at before that I like to call chat literacy. So it's the ability to communicate online. And the test that we actually ask people is, do you understand the difference between these three forms of okay, right? There's okay on its own, okay with a period, single period at the end, and okay with 3 periods at the end, because these all convey completely different meanings. Just even in this context right here, without real context, they mean different things. So what I like to say is, if you don't know the difference between that, it's equivalent to me to hiring someone who can't read your native language or the native language of a company. And it's a little bit harsh, and it's not that bad, because the good news is this is something that's very easy to train and learn. So it doesn't block us from hiring anyone, but it's something that you want to do early, so you could highlight a place that you should focus attention to teach people the difference. And the reason why this matters is because, for the people who know in the chat, and hopefully it's everybody, but if you say okay on its own, it's sort of just okay, it's fine. If you say okay with 1 period, that could mean that okay, you're upset. Okay, it's a very short form of saying okay, like, and it gives off a negative connotation. And then the okay with 3 period signs is hesitation. You're not really sure whether that's a strong confirmation or not. So the reason this matters is if someone uses the second form of okay, which from an English perspective seems totally fine to put a period at the end of that, you might actually scare someone. You might make someone feel like you're upset, and they might stress out about that. And so understanding the way people feel and the way your communication can affect that is really, really important. So we like to teach this, and I like to call it chat literacy. Okay, so the second section, that's sort of like how you work, right? A lot of writing, a lot of chat. A really brief overview of the tools we use and the way we think about things. And I'll be a little more brief on this side, but the second side is personal health and making sure that you could work from home every day, and be happy and be healthy. I think, generally speaking, like I said, I don't have a lot of time to go into a lot of detail here, but generally speaking, one concept is that it's very important to establish some explicit boundaries of work versus not work. And there's a lot of ways to do this. One of the ways to do this is just having a clear space for work. If you have, the privilege of having a space for your office, I always tell people, try not to put your desk in your bedroom. Just mentally, a lot of people go into chill resting mode in their bedroom. They're used to sleeping in there, and it's really hard to switch back and forth between working and seeing your bed all day. Things like that. I think other things that are very important for families is just having a discussion, a really clear discussion, to understand the expectations of each other when you're working and when you're not working, because yeah, it can be very distracting if you feel like you need to help with your family, or they're expecting that potentially when you really should be working, or vice versa. And a lot of the successful folks that I work with that have families have told me that they've had these just very clear discussions where they've set these boundaries. I know a lot of our employees actually have, like, they've more or less trained their kids in a way to know that, if the door is closed to the office, mommy or daddy is working and they don't go in. And there's just little things like that are really important as you go on. Something I've always done and I've loved, and any new hire we have that I have the opportunity to talk to, I tell them, this is the first thing I tell them actually, is to schedule a start and end time and a lunch in your calendar. Put them as actual explicit blocks before and the end of your day where people can't schedule meetings, because it's really hard. It's crazy hard without social cues of coworkers leaving the office or asking you to go to lunch or something. It's so easy to work really long hours and to miss eating. I think a funny thing is a lot of people say, oh, you work from home, it must be really hard to get work done. And it's almost the opposite, right? It's really hard to not get work done because it's really hard to get your mind off of work when you're used to that mode in your house. So I always say this, the blocks are not like, you need to be reasonable, right? If your team can only have a meeting at this one time a day and it's your lunchtime, like move it by an hour or something. I do that, but always put that out there. So at least it's a discussion. Like, do we really need to meet then? This is my lunchtime, or this is when I, eat with my kids or something, but establish these boundaries. They're super important. And then the second thing is, if you have the ability, if your company provides you some sort of budget, HashiCorp provides a small budget for this to the employees, invest in your office. Little things go a really long way. So just, improving your speaker system, getting a better monitor, getting a better chair. Those are the smaller things you could do that really add up and go a long way. The bigger thing that we do, and I've moved 4 times since founding HashiCorp, and my wife used to make fun of me for this, but like when I want an office, I always said, this apartment or this house, we can't have it because my office wouldn't have a window. It's like, I need to have a window. And it's just something that if I don't look outside, I learned that I'm just not very productive and I feel a little bit down. So just figure these things out and invest in your office. And all this personal health stuff, it's stuff that doesn't feel like a big deal, but it kind of like adds on you over time. So like I said, when we founded HashiCorp, I had never worked remote before. So the first, and the company I worked for before HashiCorp provided lunch. So actually the first few weeks of working, I was working from my bedroom and I forgot to eat lunch every single day. And the first few weeks was fine. I was really excited, happy to be working, making it happen. But then it hit me like a truck that, suddenly I was just really unmotivated and I felt like I couldn't take care of myself. And that was like pounding on. It was kind of a terrible situation. And these are just sort of the lessons that I learned both personally through being a remote employee myself, zooming in right now from LA, but also hiring, hundreds of people and managing dozens of people throughout that process and learning both the individual side of it and the employer, manager side of things, and the way to think about it. So this is a whirlwind tour. There's a lot more detail I'd be happy to go into sometime. Feel free to email me to ask questions, but hopefully that helps some people, and thank you very much.
Thanks so much, Mitchell. That was great to hear insights and experiences developing, a great remote culture. So thanks again for opening today's session. Really much appreciated. Okay, I'd now like to welcome Alex Jalk and Eric Veld of HashiCorp. Alex and Eric are going to talk about what goes into moving to a microservices world and how you can do that through leveraging Consul and Azure. So Alex and Eric, over to you.
Thank you very much. Hopefully everybody can hear me. So thanks for taking the time to come with us today. We're going to talk a little bit about where we're heading in the microservices world here. So my name is Alex Josh, and I'm a product manager here at HashiCorp, coming to you from California. And Eric is with us as well from Europe. And Eric will be jumping into the session in just a few minutes. Let me just change this around. So what we thought we'd do is just real quickly talk about what Consul is. Hopefully you've heard of it, and it'd be even better if you've used it. That'd be fantastic. But just for those of you that are kind of new to this, we'll just give you a very, very brief discussion about what it is, and then we'll get into some details of how it works. And Eric's got a pretty good example of how you can actually use it. So one thing that's really critical to thinking about Consul is to think about how compute and computing has moved in the cloud era. So if you think about this migration from physical servers to virtual machines and then containers, really what it is it's the movement of sometimes referred to as pets to cattle, right? So we had a small number of objects. I'm old enough to remember when the servers all had very specific names. The first server I ever managed was named Venus, and we had all our servers were named after planets because we only had 6 of them. If you have 45,000 containers, that naming scheme probably doesn't work for you. And so the complexity that is brought to the table has caused us to embrace things like automation, like automated builds and things like Terraform, and all these other pieces are really helping us do that. And Consul is just another piece of that same puzzle, and it helps us move forward in similar ways. Oops, wrong key, there we go. So if you think about what was happening before, if you had a very small number of relatively static machines, then your networking boundaries and the way that you talk to objects was relatively static. You would deploy a subnet, you would put objects into that subnet. Sometimes you could even have the luxury of having a subnet be a single purpose. So you'd have a subnet for application A, the database is there, the data tier is there, everything's there, and you're done, right? Maybe you put some hackles on your right, or maybe you don't. But as things get more complicated and more dynamic, which is what we want the dynamic nature and the ability to scale, that model kind of falls down now. Now you're talking about having service A talking to service B. Service A may be comprised of 10 containers, service B might be comprised of 100 containers. Maybe they're running on the same server, maybe they're not. Doesn't really matter. And so that flexibility brings huge power, but it brings complexity, right? And so the idea here is that instead of a traditional static approach to networking, Consul is focused on this kind of very dynamic way of doing it. So there's a couple of different parts of this, and we'll get into this. But the idea is that you would use things like service discovery to find the objects in your network that you want to talk to. You have segmentation, so you keep them apart. And then you can also do things like storing key value pairs so that you can do discovery and dynamic configuration if you need to do so. So everybody kind of has the same view of the reality of what's going on in the network. So the summary here, and I apologize, we're going like super fast because we're trying to be very focused, is that Consul basically has 3 kind of core use cases. We refer to them as service discovery. And what we mean by that is like I can declare myself as a service, as an object, and saying, hey, I have this service, I'm service A, and here's where I'm listening. That's expressed as, can be expressed as DNS. Also segmentation, right, where we have these 2 objects that want to talk to each other, probably 2 containers, or it could be a VM in a container, or really anything actually. And then they can form a secure connection to talk to each other. And Consul manages that for you. And then the kind of key value store functionality, which is kind of core to what Consul is. But the idea is that you need to be able to push dynamic configuration information someplace and have that stored in a pool. You need to have multiple members sharing the same information. You need to have it distributed. You need to have it eventually consistent, and Consul brings all that capability to you. So that's kind of the 10,000-foot view of what's going on with Consul. However, what we really want to focus on now is how you consume Consul in the cloud. We have a lot of customers that are running Consul right now in AWS or Google or Azure or their choice of clouds. But one of the things that people have told us consistently is that what they would really prefer is that Consul is available as a service. And at HashiCorp last year, we announced our intention to do that. So what is Consul as a service? So Consul as a service is exactly what it says on the tin. It's a way for us to deliver Consul in a managed format that you can consume without having to worry about the tedious details of actually deploying it, managing it, patching it, sizing it, responding to trouble tickets if a host goes down, all those kinds of things you don't have to worry about because we take care of it for you. It's a completely managed service. It's owned, operated, managed by us, by HashiCorp employees. And we're delivering it at the moment on Azure. So the idea here is that you can relatively quickly and easily deploy clusters in Azure and then consume them across your distributed applications, whether they're running in AKS or running in a VM or pretty much any form factor you want. As I mentioned, it's fully supported. I think the biggest piece of this is probably patching. Most of our customers, when we ask them what are the top favorite features of Consul, they don't say that patching is their favorite feature. Nobody likes that. That's not the fun work that you get to do. So we can take that work away from you and make sure that we keep the servers up to date, that everything's patched, everything's secure. Especially if you have something urgent, like an emergency patch due to a 0-day vulnerability or something like that. It's not something you want to stop your regular work to fix, right? You want us to take care of that for you, and that's what we're doing here. Because it's the core Consul functionality, the use cases we talked about before, like service discovery and full service mesh, will work in Consul as a service. I think it's really important to note that just like all of our other products, HCS is very focused on making sure that we carry forward all the goodness that comes from the open source products. Obviously, the open source version of Consul is very critical to everything that we do here, and the community around that is super critical, so we don't want to walk away from that product. So the core bits are there. It is Consul. If you know Consul from open source, you'll be very familiar with Consul as a service. So what does that really mean? Well, it means that when you go into Azure Portal, you can go and configure Consul resources. You can deploy a cluster. And in fact, I'm going to show you a demo of me doing that in just a minute. The core access to this cluster is managed through Azure Active Directory, as you would expect. And then the billing comes through your Azure bill. So if you are an Azure customer and you like being an Azure customer and you want to consume that way, then you'll be able to do that. And this is definitely designed for customers that have chosen to use Azure for some portion of their compute needs. So what does this look like? So there's a little bit of complexity in that this is what's called a managed application in the Azure universe. And so what that means is that there are actually two resource groups involved in the deployment. One is the resource group that you own, the customer resource group in this picture here. But what we do is we introduce a new resource group that is the managed resource group. This is managed by us, by HashiCorp, and this is where the actual Consul objects are deployed. And we deploy our own VNet. And then the idea is that when you want to connect other services to this resource group, then you would use VNet peering in Azure to do that. Mechanically, under the covers, the way it actually works is that the marketplace, the Microsoft's Azure marketplace, calls us through a well-known API. Our backend services then provision and manage those resources. So there is a shared responsibility model here. We do have full access to the underlying Consul hosts because we're responsible for them. We patch them, we maintain them. So we have protocols in place to make sure that those objects remain secure and there's not unauthorized access to them. Human beings at HashiCorp are not sitting there logging into these hosts. That's not what's happening. They're being managed programmatically in a secure way. And so the idea here is that you have a long-running managed infrastructure that is supporting your custom applications that are sitting in the resource group that you own. So let's make this a little bit more practical. So the process of actually deploying HCS takes a little bit of time, which more than we have at the moment. So I cheated a little bit and I recorded it. So this is kind of like my cooking show here. So when you go into Azure Marketplace, you actually see the offer here. Oops, clicking in the wrong place. And when you create it, as we mentioned before, you have these two resource groups. You have the resource group that you manage, which lives in a given region. And then what you do is you just give the application a name. This is the name of the actual managed application in the Azure side. And then you have to give Consul a cluster name. So this is exactly what you would think it is. It's just the standard Consul functionality when you deploy it. I'm going to leave all the other fields blank here. And then you go through a really quick validation section. You have to accept the ULUP, all the normal stuff, and then you click create. This is the part of the demo we're going to compress a little bit here because this takes about 15, 20 minutes. And my entire presentation is 12 minutes, so we didn't have time to do the whole thing. So we're going to go ahead and compress it. And when it's deploying, you see this kind of status message here. And it just kind of gives you the kind of holding pattern, tells you what's going on. So I'm going to exit out of here. So that was kind of the prepared cake part of the cooking demonstration. So now we have our lovely risen souffle here. And this is a running live environment, so we're no longer in the video. And what you can see here is in my Azure console, I have a managed application. This managed application is a Consul cluster. If you are an Azure user, hopefully this is fairly familiar to you. It looks a lot like an Azure object. There's one little trick here, which is that we've introduced this new section here in this tab. And when you click on this, what you're actually getting is just full-on Consul, exactly what you would expect. Now, if you've ever used Consul before, hopefully this UI is very familiar to you. Obviously, you can interact with this also from an API or CLI, just like you normally would. So at this point, what you have is a full normal running Consul cluster, and all the normal Consul cluster things would apply. So we're going to shift gears here a little bit, and I'm going to hand off to my partner in crime here, and we'll talk a little bit about what you can actually do with this thing once you have it running.
Okay, so let me stop sharing video so I have as much screen space as I possibly can. So thank you, Alex. Good morning, everyone. It's very early here. I'll be taking the setup that Alex has just shown with the Consul cluster, and I'm going to show you how you can use that to actually migrate from a monolithic application running on a VM and move that to microservices running on Kubernetes. So in the case of what Alex just presented, that would be AKS, right? And I have about 10 minutes to do it, where normally companies take months or years. So let's get started and go through this quickly. To speed things up and make it possible for you all to download this demo afterwards and play around with it yourself, I've created a local version of the environment using a tool we have called Shipyard. So we'll be simulating a few things, but the interfaces remain the same. So the lessons learned will still apply here. So we're starting off with this situation where we have our virtual machines running our monolithic application. We have a payment service, which is the big monolithic application, which is fronted by a proxy we call web. And there's the AKS cluster and there's HCS, but they're unused for now. And the proxy is actually statically configured to route traffic to the IP of the payment service. So this is a quite fragile setup. What we actually want to move to is to a microservice architecture where the applications are running on Kubernetes and they're split off. In this case, we've split off one microservice, the currency service from the payment service. And all these pieces are communicating with each other through the service mesh. So this makes everything way more robust, dynamic, and secure because the applications can find each other through service discovery. And then all communication through these sidecar proxies is actually encrypted with MTLS. So as I said, we're simulating some of the components in here, and that's to make it easy to run locally and quickly. And one of those things are actually the VMs themselves. So instead of having VMs and waiting for them to spin up, we're actually using containers with multiple processes in there. And in this case, we'll have our application binary, a Consul agent configured as a client, which is connected then to HCS, and we have our sidecar Envoy proxy, and this is all managed with Supervisor. So let's start making the first step from that statically configured environment, and we're going to migrate towards these microservices. So first, an easy step that we can do is take that proxy and already move that to Kubernetes, right? It's an Nginx or an HA proxy, and there's already containers for that, so it can easily be migrated. But then the important step, what we need to do is we need to register these services in the Consul service registry, and then launch sidecar proxies for these that then get configured through Consul to make that communication between these services possible. All right, so let me hop on over to code and show you how we do this. So here we have the service registry for the payment service, and all. Hello, I think my Zoom just crashed, so let me quickly reshare.
Yeah, Eric, we can hear you again now, but you did break off for a moment there.
Yeah.
Oh, where did it cut off?
About 30 seconds ago.
Okay, so that's about when I went to code, right?
Yeah.
Okay, the wonders of the internet during this time. Okay, cool. So here we see the first service that we're going to register, and we have to give it a name. So in this case, we give it the name of payments, and we specify the port that it's listening on, so other applications will actually know how to contact it. I'm giving it some metadata, which will be important later on. So I'm giving it a metadata version, and this is the first version of this service. And then very importantly, we're actually specifying that we want a sidecar service for this actual service. So it'll actually spin up an Envoy proxy for us. And then here we've containerized the proxy. I'm just using something called fake service to actually show the call chain in here. And because we're running on Kubernetes and we've installed the Helm chart for Consul, we actually can make use of some very useful features. So we're actually going to inject the sidecar proxies automatically if we have this annotation set up. And then since web needs to contact payments, we actually tell it that there is an upstream. So we want to be able to reach payments, and we want to do so on localhost 9091, which, as you can see, I'm actually calling here. And then very importantly, because we actually want to use the L7 features of Consul Service Mesh, we set the protocol to be HTTP, right? So we actually have this already up and running. Go back here, move Zoom to the side because it's always in the way. And we can see that we have Consul running, but we also have our two services, payments and web, and their sidecar proxies. And if we actually test this, we can actually see that web can contact payments, right? And web has an IP in the Kubernetes space, and then payments still has that static defined IP. Okay, cool. So now that these applications are meshed together, we can actually start with the more important migrating part of the move. And we're going to split off pieces of functionality, and we're going to do so step by step. So we're going to start off with a simple encapsulated feature, the currency feature, which is right now a in-process call from the payment service to the currency. And we're going to split that off into its own little microservices. So currency v2, which we can then call separately, right? So let me show the YAML for that, and we can actually start applying these. So here we have the currency service. It's a very simple microservice. It just responds with the amount of money that it is in a certain country. So if we input $10, what do we get back? Well, this might be Australian dollars. And again, we're injecting our sidecar proxy and setting the protocol to HTTP. So let's actually apply this. So I'm applying this entire directory right here. and it's actually sending in Kubernetes YAML, as we can see. So if we go to Consul, we now see that we have the currency service and the sidecar proxies up and running. Okay, but we don't have any way to call it, right? If we call /currency, we still end up at the payment service. So we want to expose the currency service, but we don't want to interrupt any of the traffic for our normal users. So what we need to do is apply a service router. And I'm going to apply a service router for the payment service so that when we call /currency, that normally gets routed to the payment service, we actually redirect to the currency service instead. So let's do console config, right? So this was v3/that. And we've now applied this central configuration. So that means that if we now would try this call again to /currency, we actually end up at currency. And if we go to anything else, we actually end up at payments. Great. So now we can actually test this feature separately and make sure that everything is robust. All right. Oh, switch back to the slides. So now that we have this microservice for currency, we need to actually start using it. So we're going to deploy a new version of the payment service that actually calls this microservice instead of doing an IPC. And we want to route traffic to this new version, but only if we are a developer of the application. So to do this, we will actually split the service of payments into two subsets. So we're going to have the old version, that's where the metadata comes in, version 1, and we're going to have version 2 of this. And then version 2 will have an upstream of currency. So let's switch back to code and actually do this step. So here we have our new payment service. I've already put it in Kubernetes, but that's just for ease of use in this demo. We're again going to inject the sidecar service. And we have an upstream of currency that we want to reach on localhost 1991. And again, the protocol is HTTP. And here we're calling that upstream service, right? So let's apply this configuration. So that should now be spinning up. We should now have a extra payment service in here. Here we have the old one, and this one's actually on AKS. So that's all going well. But now we need to be able to call this. So we want to configure it the same way that we did with the currency. So in order to do that, we actually first need to create these two subsets. So we need to specify that we want two subsets, one for v1 if the meta version is 1, and v2 will be if the meta version is 2. And then very importantly, we define that the default subset is a v1, so all our current users are actually still being sent to v1. So let's apply this configuration. Okay, very cool. Now, if we actually test this and we go to a route, we get the old payment service, but we also want to be able to reach our new one. So in order to do that, we'll create another service router, again for the payment service, but this time we'll try to match on HTTP headers. And if the header says that we are in the group of developers, we want to actually route to a subset of payments. So we're actually going to route to v2. So if we actually apply this, we can now give this a go. So curl 9090, and as we can see, we are ending up at the payment service. Okay, that's all good. And what if we pass in our headers? We actually get routed to v2 and the currency microservice. So this means that we can actually test this service without disrupting any of our users while this is going on. So heading back to this. So now that we've been testing this and we know that the service functions properly, we can actually start to expose it to our end users. And we want to do that slowly. So we're going to create a canary release and give it to a small portion of our users and see if everything goes well, and then ramp that up from there. We'll then ramp it up to 50%, see if everything still goes well. And then if there are no errors, we'll keep an eye on our monitoring tools. We can actually switch over 100% to the new version. We can keep the old version around, so in case we do get any errors or find any bugs, we can always roll back just by changing these values in the traffic splitter. And eventually we can decommission the old version and start breaking off the next piece of the monolith. So let's actually switch to that, right? So here we have the initial service splitter, where we use these same subsets that we've defined before, V1 and V2, and we're going to set the weight 100% on the current version, right? So we'll actually write this configuration, V5, and let's do 100% to the current version. So if we curl localhost 9090, we actually see we still get the old version. Good, 100% is going there. Okay, so now that we have this in place, not author Nick, he didn't do anything. We're going to ramp it up to 50%. And we started exposing this to 50% of our users. And with sticky sessions, they would only get that current version. So we can see that we get a healthy split between the old and new version. Everything is still going great because we don't create bugs. It's the users that do those. And we're now switching to 100% our new version. And all our users have now migrated to this new version. Now, the cool thing is that we've been doing this by only changing configuration mostly, right? We've had to split off that microservice, but we haven't interrupted any of the service for our users. And by doing it this way, we can actually slowly move towards a microservice architecture instead of having to do a big bang transition, right? If you would like to try this out for yourself, check out this repository. It contains everything you need to run the demo, and it has written instructions on each of the steps. It actually opens up documentation when you run it, and it takes you through all the steps as all the screenshot and all the commands you need to run through. And it's entirely self-contained, so please give it a go. With that, thank you, and I'll hand it over to the next speaker.
Great, thanks Eric, and thanks Alex. A great overview of HashiCorp Consul service on Azure and service-based networking for Consul service mesh. So thanks again. I'd now like to welcome Lachlan White from AGL Energy, who's going to share a real-world story around unlocking cloud with GitOps using Terraform and Sentinel. So over to you, Lachlan. Thanks.
Awesome. Hey, everyone. You can see my screen all good there?
Yep.
Awesome. Perfect. So a lot of content to get through and a little bit of time. So let's see how quick we can get through it. So we're going to be talking about GitOps and how we use Terraform Enterprise and Sentinel to unlock cloud, you know, through GitOps as our journey. And a little bit about me, the DevOps architect in Australia. We were lucky enough to be the first production implementation of Terraform Enterprise in the ASX 50. And I've got an identical twin, and he'll appreciate being on record as the smarter twin. So let's just get right into it. So why is cloud so hard? A question that comes up a lot, and I think that this Dilbert comment sums it up really well, is that people tend to focus a lot on the technology aspect. So this interaction between an architect and an executive talks about why didn't cloud solve all of our problems straight away? And really, you know, the executive response is another technology option. Just put it in containers, and then when that doesn't work, Kubernetes. If we, you know, it hurts how close to home that hits. And if we really break down, you know, what the majority of the main challenges that are faced in this, we look at the change in the service model from a traditional IT service model to a cloud native IT self-service model. And we'll have a look at that in the next slide. And then we look at the culture change and impacts that have happened and what's needed to move from one offering to another, and how a company likes to operate in those environments. And then, of course, speed, risk, and cost come into it. The cloud can be in a remarkably fast-paced environment, but that speed can get you in trouble if you're not paying very careful attention to the risk and cost aspects of that. And we'll look for a little bit of that in the responsibility model a little bit later. But how do we solve these issues? Well, we turn to GitOps, and my definition of GitOps is using Git as the source of truth for the management and deployments of cloud-native technologies. And why I say my definition is because WeaveWorks, who originally coined the term, specifically coined it to manage the deployment and application deployment of Kubernetes clusters and applications. And so I think that now, with the tools that we have available to us, we're able to broaden our horizons with that and look to manage all of the cloud as we go. So GitOps, we spoke about that transition from traditional IT to cloud native IT, and what role GitOps plays in that environment. And in a traditional IT world, where we're looking at ITIL as our system of management, where people are managing systems, there's very clear roles of who's responsible for what. We have oral tradition, very spoken tradition. John looks after that service, Mohammed looks after this, and it's very clear who is responsible for what. But when we try and move that system of management to cloud, we end up getting a lot of process friction. And it's when we try to run those monolithic processes in a loosely coupled way for cloud native technology, that process friction really comes through and causes a lot of issues for us. When we're in the traditional world, there's one data center or maybe two for DR, but that's kind of all we have, and it's very hard to change and costly, and it's very risk adverse. Whereas when we're in the cloud, we want to be much more free and open to innovate and have a lot more scalable capability. So how do we look at achieving that? Well, excuse me. So at AGL, this internal open source, or inner source, as it was coined by Tim O'Reilly in 2000, is kind of what we turn to. And what inner source means is that we use open source software development best practice internally within our own organization to establish an open source like culture. And when we talk about HashiCorp products, that's kind of at the core of their belief. And one of the links I've got here is actually from Armin Dadgar, who's one of the co-founders with Mitchell, who spoke earlier, and now the co-CTO as well, talking about a typical journey from ITIL to DevOps. And he uses this term of decentralizing the trunk of enterprise technology. I really recommend that video, but what I took away from it the most was we have this trunk where we want to have the main core capabilities, and we want to enable development teams, platform teams, DevOps teams, whatever we call them, to contribute to that centralized capability and then build up on top of that themselves. And when they're building up on top of that, we're hoping that they end up building these green applications or leaves that kind of mean we're not reinventing and fighting for money and food and water, as that helps that tree grow and that business prosper. And how we achieve that is by this inner source culture. And the more we use it, the more we start to reap rewards around reusability, flexibility, faster time to market, and importantly, better employee motivation. And I'm lucky enough to have been in a team where it is very community driven and everyone's really keen on collaborating on infrastructure as code and networking and other bits and pieces. There are a lot of pull requests that come, but they turn into kind of an audit engine, and we know who changed what and why did that happen, and we can kind of use that to base, all of our bits and pieces off. So how do we kind of visualize that transition? So, whether you want to call this an operating model or a responsibility model, when I put this visualization together, it was really to illustrate just how much change is needed in that journey from an ITIL-based traditional IT data center approach to a cloud native one, and how a lot of enterprises today actually find ourselves somewhere in the middle in this hybrid IT world. And what happens is, as you can see in this traditional IT world over here, as I was saying, there's an app team that looks after apps, a middleware team that looks after middleware, data, and this infrastructure team. And everyone's very clear on what they do. And it typically happens in this on-premise environment. And if I was looking to build an application in this, like a payments microservice or something we were just talking about before in Consul, I would have to go and request a network address space from the network team, and then go and request a server from the infrastructure team, and then go and request a middleware if that was needed for my app, and then production data access, then maybe manually load my application into the infrastructure, or maybe we do have a CI/CD pipeline, who knows? So all of these steps add so much time to the process I have to go through. And when we start to move into this hybrid IT world, things are a lot more confusing. We have this DevOps team that's attempting to run everything end to end, and we still have these other teams potentially that are trying to hold on to their domains. And this gives huge overlaps of capability, huge grabs for territory and battles for control. And it's almost impossible to know who to speak to for what. And it's not an ideal scenario, but if you do learn who to go to, it can be faster. And a lot of companies have seen that reward, but what's the cost of that? Is there an increased risk, increased complexity that comes with that as we move towards more of this cloud-based solution? Now, the goal is to get to this cloud-native IT world where we have GitOps as our driver and our answer to solving these problems. And in this, everyone has the same shared responsibilities as we start to leverage more services such as containers as a service like Kubernetes and serverless functions like Lambda or functions in Azure. So at AGL, how did we look to use this? Well, we look towards Terraform Enterprise as our abstraction away from this. And very quickly, Terraform Enterprise is the enterprise offering of the open source software of Terraform, which I'm assuming everyone knows. And it has over 200 providers, from everything from our main public cloud providers like Azure, AWS, GCP, but also GitHub and New Relic, and even Domino's Pizza. And some of the dev advocates have made an awesome presentation on trying to order a pizza through Terraform, which is pretty cool to go and look at. But to really cover off why we looked at Terraform Enterprise, if we break down what we get out of Terraform, we get these modular and reusable pieces of code, which really helps speed up how we approach building and developing software and infrastructure. And it's easy to introduce into our teams because it's extremely human readable, and we don't need to spend lots of time training people on how to use these services that we've built. And my favorite part about Terraform is extendability. So how we can use any of those 200 providers or make our own providers on top of what's there originally to extend things. So maybe I want to enable a developer to build a Azure subscription, but then also deploy an Azure DevOps project and pipeline with a secure connection. And I can do that all from singly using Terraform. Now, Terraform Enterprise is really where we start to think about the scale of enterprise and how do we address those problems. And for me, the collaborative infrastructure of code experience where we all have workspaces with RBAC separating everything is really key. And then looking at how we can use Sentinel to take care of our compliance aspects and enforce tagging and other bits and pieces we'll cover a little bit later. And then also the security aspect. So, single sign-on is hugely important of data, using the Vault backend, for example, in Terraform Enterprise and audit logging. And then the scale side of it, we run loads of concurrent jobs. In the middle of the day could be up to, a couple, 150 to 100 concurrent jobs. And being able to control that through our custom worker images that we manage is really important. And then also looking at the new clustering data that's there gives us a lot of flexibility. So that's really, really quickly the difference, from our added benefits of Terraform Enterprise. And we had to focus on how we look at working with these tools and technology. And one of the biggest premises that we have is abstraction. So how do we enable teams to operate on ideas rather than individual events? So if we wanted a developer to deploy a full application, how would we go about doing that? Well, that might be 40 or 50 different steps to get to production. How do we make that as simple as possible so they don't need to know every intricate little step that's required to actually deploy that application and that infrastructure? And so to really unlock that full value of cloud, we realized we needed more than just this operations team here, looking at the private module registry. And we needed everyone to get on board. And that's really where that inner source mentality and culture helped to try to uplift how we worked as a company. And we couldn't just open the doors and let everyone start to raise pull requests to our modules, because we didn't want security to be trying to lock down apps so that developers couldn't work. And we didn't want developers to be trying to open to the world. We needed some kind of way to control these things. And so something like this, which is a bit hard to read, I apologize, but I made something called this zone model where we look to break down the resources that we have in Azure to specific security boundaries. And if we look at the coloring that's here, it's very similar to what we had on that responsibility model, where we have security and networks, cloud ops, and the application teams. And they all kind of want to own little bits and pieces of the kind of the landscape that we have across Azure. And my favorite example of this is subnets. We've got a subnet, an application subnet here, where we have the network team that care about what address range that's in. We have the application team that care about how that's talking between their app and data subnets. And we have the security team that care whether or not that's publicly facing or poses a risk to how that operates. And so how do we enable those teams to work together? And again, it's GitOps that's the answer for that, and how we leverage Terraform Enterprise with its VCS providers to enable us to do that. And so if we looked at that example of a developer wanting to write a piece of code, here we have a developer who just wants to push things into production and test and dev environments into Azure. He wants to run a container application. And this is not all of it, but these are all pieces that he needs to be successful for a production enterprise application. We need to have a GitHub repo, a subscription in a management group, tags across our resource groups and networks and container registries and Azure DevOps project and billing information. And so rather than have this developer have to look after all of that themselves, we have all of these teams that are able to collaborate together on these individual modules and hide a lot of that complexity away from that developer and end user. So how does that actually look as code, right? That's the interesting part. So when we had a new developer onboarded, as a developer, I need a GitHub repository to store my application code. Well, how can I do that? Well, we have a central repository and Terraform workspace that looks after GitHub repositories. And all they need to do is raise this new 5-6 lines of code that deploys a module that has the complete encapsulation of what we define as an enterprise-ready GitHub repository. And that will deploy that for them by them just providing our repository name, which is obviously a new money-making product that we're going to make millions of, and what the description of that is, and which team in GitHub needs access to that. And so by doing that in one pull request, they're enabled to start writing their code straight away and adding value to the business on day one. When we look at then how a dev or an engineer needs to deploy new application infrastructure, again, we want to make sure that they're deploying into a specific workspace for their application, and they're using the modules that we have that have all of our controls that are ticked off by security, so we don't need to reinvent the wheel every time. So here they're adding a name and location, a resource group, and these are a bit simplified to fit on the screen, but essentially that will build them everything that they need to be able to deploy that application code into a web application in this instance. I did a speech on a user group on Terraform at Scale that covers a lot more detail about this. So if you want to check out some more about that, it's listed down there. The last one though that no one ever talks about is networks as code. And it's one that DevOps never really want to touch. But again, we have a module for that. And if we look here, there's a source module, a specific version. We have our information here, our resource group name, where do we want it, the size of the address, the name of the network, and whether we want it connected on the express route. What's amazing about this module, nowhere have I asked you to give me an IP address range. So we actually in our module point to an IPAM solution that can actually call the next IP available range of that size that you want, in this case a /28, and then automatically using some of the inbuilt Terraform functions, split that into 3 even subnets called web app and data. And so you're able to really fast track how that works for the developers. And the benefits we start to get of that is previously we had all of these concerns on the developer who just wanted to develop and deploy their application. So infrastructure, costs, security, operational concerns, how the network work, risk compliance. And all they really want to do is be efficient and add value to the business. And so what we want to do is, and what we have done is use Terraform Enterprise as kind of that central hub where that capability is now available for them to just develop and then deploy. And we have parties helping to contribute to this massive shared internally facing open source community on how we best do cloud native technologies at AGL, which is super exciting. And we start to get these benefits of governance and compliance, cost visibility, increased developer productivity. And as a result of this program we ran, we actually bought our data center exit 2 years ahead of schedule, which is a massive money saver for us. And so the one thing we haven't spoken about so far is like the security role in all of this, and how do we make sure that we're managing the security aspects of this from within Terraform Enterprise. And that's where Sentinel really enters the equation. So it's itself, but it's a feature of HashiCorp stack, and it's a policy as code framework. And it works on any of the enterprise offerings and in Terraform Cloud of Consul Enterprise, Nomad Enterprise, Terraform Enterprise, and Vault Enterprise. And what it really is for us, it's a point of control between the defined and the real state. And and we can use that for things like security controls, tagging, as I mentioned earlier, and even identity management. And so one of the examples that I've got here is how we use Sentinel for tag validation in Azure. And so for those that don't know, tagging in Azure is absolutely critical for reporting. So we can use it, and other organizations use it for ensuring tags on cost code and ownership and application names, even CMDB IDs if we're forced to. And people always ask, why don't we just put those modules? Well, if we started to hard code those in the modules, the day that we have to raise a pull request across our 400, 200, whatever, how many modules we have, that's a lot of pull requests with the same change. And we want to really leverage that one-to-many mentality. And so by having Sentinel scan every Azure resource that can have a tag, and make sure that it has these values from a single point of control, we're able to manage and trace across all of our workspaces from Terraform Enterprise if those resources have met our requirements from a compliance point of view for tagging. And then we can also validate that within Azure policy itself. So we have the ability to manage that defined state and then the observed state on the deployment side. And one of the reasons we pushed this out of Azure was because of some issues we faced with deny rules and scale out issues that we faced in Azure. If we tried to scale a virtual machine and there was a deny rule for tags, sometimes that machine wouldn't build because it didn't inherit the tags correctly. So that was obviously an issue we wanted to correct. So what else do we use Sentinel for? So we use Sentinel for an enablement piece. So when we have some rare instances where we want developers or engineers to deploy things that would be classified as a privileged change or resource, we don't want to just give them the access to do that. We want to take a least privileged approach. So things like creating an Azure subscription, peering a VNet to the hub, creating or adding an Azure AD group to another resource group they manage. We can use Sentinel to whitelist specific modules that we have that only perform those actions, and therefore enable teams to become self-sufficient and manage that entire workspace and blast radius themselves. And so that's really the glue that enables us to go from this kind of hybrid IT world to everyone working cohesively together. That least privilege approach and using Sentinel as kind of our distraction and like our governance between that is a really, really useful feature that we would have been stuck without and was kind of a bonus to us when we started to try to look at using it. There's also new things like budgeting that's become available in Sentinel as well, or cost estimations it's called, that we're looking at using. That we can't wait when we can use enterprise price books for that. And that's kind of how Terraform Enterprise and Sentinel have like enabled us to use GitOps in a way that unlocks the value of the cloud. And I know we're not taking questions today, but I'd like to thank the sponsors and HashiCorp for throwing on this event at such short notice from the change of the HashiDays event that was in Sydney. If you have questions that I can't get to in the Q&A, hit me up on LinkedIn or Twitter. I've written a couple of articles on Medium and be more than happy to answer any questions you've got. So thanks very much for listening.
Great, thanks Lachlan. Great presentation. And thanks for sharing your story around using Terraform and Sentinel. Trying to unlock the
No worries, guys. Thank you.
That's good. And thanks for your support. So now I'd like to welcome Nick Kabatoff from HashiCorp, who's going to show you how to keep a secret with Vault. So over to you, Nick, if you're ready.
Hello, everyone. Thank you for coming. Today, we are going to learn how to keep a secret, more specifically, how to retrofit your applications to use Vault. Oops, sorry. I'm just getting the hang of my clicker. My name is Nick Kabatoff. I'm a developer on the Vault team at HashiCorp. Before we get into the nitty-gritty of how to modify your applications, let's make sure we agree as to what secrets are and why they matter. So data breaches are happening all the time these days, unfortunately. And the consequences can be quite severe, both for the breachee and the victims whose personal information was stolen. So there's a well-known example of a big credit reporting company that a couple years ago lost 100 million people's data, driver's licenses, credit cards, etc. And they've been fined over $1 billion, let alone all the impact on those people's lives. So you want to avoid that. And that's why we care about securing our secrets. What is a secret? One definition is that it's something that would increase your risk if an unauthorized person got it. And the risk is a risk of harm, including things like identity spoofing, exfiltration of private data, and so on. And we can draw a distinction between secrets and sensitive data in general, where sensitive data is anything that's confidential, anything that would cause harm if it leaked. But secrets are the keys to open the floodgates to sensitive data. These are things like database passwords and cloud credentials and so on. So we're going to focus on protecting the secrets because there's orders of magnitudes less of them. And if you can protect the secrets, the sensitive data should be safe too. So forget about computers. How would you keep a secret if you had to? Well, I think we learned very early on that the best way to keep a secret is to tell no one, or if you must, as few people as you can. And if you do tell people, you should keep track of who you told so that you know who to blame if the secret leaks. And this isn't very practical for personal secrets, but for the kinds of secrets we care about, it's possible not to have long-term secrets, because the longer you keep a secret, the more likely it is to eventually leak. So you should be rotating your secrets as frequently as is practical. Vault can help with these things. First of all, it lets you centralize your secrets, and that's kind of a prerequisite to have any kind of control over them. If you have secrets sprawled all over the place, there's no good way to really keep tabs on them. If you use Vault, then any clients that want to connect to retrieve secrets are going to have to prove their identity by various mechanisms. And like I said earlier, we want to rotate secrets frequently, so Vault makes that easy. And audit logs, in conjunction with these other things, lets you see what's going on, and in the event of a breach, lets you take care of it as quickly as possible. So to onboard your applications, you're going to have to solve two problems. You're going to have to figure out how the applications will authenticate to Vault and how they're going to get secrets from Vault into their memory. And since secrets are going to be rotated periodically, it's not just at startup, they have to get the updated secret whenever they get rotated. The first problem of authentication is actually harder than you might think, and it's hard enough that we've got special names for it in the community. So we call it the secure introduction problem or the secret zero problem. And it's kind of a chicken and egg issue because you want all your secrets safe inside Vault, but how are you going to prove who you are, that you are who you say you are, if you don't have a secret like a password or something to identify yourself? So there's various solutions depending upon the environment in which you're running. If you are running in a cluster scheduler like Nomad or Kubernetes, or if you're running in a cloud like AWS, then there is an API that Vault can use to validate that you are who you claim to be. And so that's usually what we recommend in that scenario. But if you are running on-prem, let's say, not within a cluster scheduler, then you're going to have to do something else. And that's what the topic of this talk is. You may also want to do something else if you want a uniform solution across all of your environments, for example. There are some best practices we're going to try to follow for any solution to secure introduction. We already said we want to rotate the secrets that we're protecting inside Vault regularly, but the same applies to the authentication secrets that you're going to use to identify yourself to Vault. We also need to make sure that we distribute those authentication secrets securely. If those authentication secrets get disclosed, we want to minimize the damage they can cause, and there needs to be a break glass procedure to follow when that happens in order to contain the damage. And of course, you have to actually detect the unauthorized access in the first place in order to follow that procedure. So some spoilers, the way we're going to address points 1 and 2 are primarily, I mean, other than encryption on the wire and so forth, are to use credentials that have limited uses, ideally a single use, and that have a short lifespan. And these are parameters that you can specify in Vault when you set them up. To limit exposure, you should use the principle of least privilege. Just as when you're setting up a database role, you want to ensure that it has, that it grants the minimum privileges that your application needs in order to read just the tables with whatever privileges it needs. Similarly, when you set up Vault policies, you should be minimizing just how much access you're granting. As for the break glass procedure, this is going to be the same regardless of what you're doing with Vault. If there's an incident, you're going to use the audit log to see what was accessed and to revoke any credentials that were granted inappropriately. And as to detecting unauthorized access, we'll come back to that in more detail, but to some extent, this is going to fall on your application's shoulders. So how to do secure introduction on-premise without a scheduler? There's a few different options, but these are the three big ones, I think. The first is you deploy a Vault token directly. The second is you deploy an app role ID and secret ID, which allows obtaining a Vault token through a login API call. The third option is use TLS client certificates, and then with that you can connect using the cert auth method to also get a Vault token. The client certificates is not substantially different from app role in most respects, so in the interest of time, I'm only going to focus on two, and on app role that is. And as for deploying a Vault token, this is all I'm going to say about it. Just again, in the interest of time, there is another talk I'll refer to at the end that gives more details on this. So you might want to distribute a token instead of using app role if you want to use env Consul or Consul template, which are some helpers I'm going to talk about later. If you do decide you want to distribute tokens, you should use a token role, which is similar to what we do with app role roles, as you'll see in a moment. This allows you to set policies on a per application basis. You would also want to distribute a short-lived token, preferably with a single use allowed on it. And you probably want to use a Vault feature called response wrapping that allows that token to get access to other tokens. Again, this is covered in more detail in the other talk. I'm just giving you the highlights. So suppose you want to use app role. You need to do basically a three-step process, or maybe four-step. You need to, as the administrator, a single time, you're going to enable the app role auth method and set up a role within app role that has the policies that grant the privileges your application should have. This is also where you would set things like token lifespan and number of uses and so on. You would also have to define the policy if you haven't already, so that's why I said maybe 4 steps. Then I have this labeled as the deployer, but it's more likely to be your deployment pipeline or your configuration management system or something like that, are going to fetch the role ID for the role and create a secret ID associated with the role. So the role ID is kind of like the username, and the secret ID is kind of like the password. So your application, once it has the role ID and secret ID, can do an API call to the app role login endpoint, provide those role ID and secret ID as parameters, and they should get back a token if they were valid. And then with that token, you can fetch secrets. So this does sound a lot like username password. Why do we have both a user pass auth method and an app role auth method? User pass is really intended for humans to use. App role has some additional features that are more beneficial for applications. One of those is that you can't have multiple passwords for a user, but you can have multiple secret IDs for a role. And this allows you to say, have a single role that represents what an application needs, but then every instance of the application or every deployment of the application can get its own secret ID. And those secret IDs can be tailored. So you can say, for example, this secret ID can only be used to log in from this specific IP or IP range. Or this secret ID has 1 use, but this secret ID has 5, depending upon your needs. This is one example of a workflow you might use for app role. There are other possibilities. So here at the beginning, we have the administrator or security engineer that's setting up the app role. And then someone is going to take that role ID and make it available to the application. Maybe you're going to put it in the source code. Maybe it's just going to be an asset bundled with it. And then something is going to get that role ID and fetch a secret ID for it and bundle them so that the application can get them. Maybe you're going to do this as a single step. Maybe you decide you don't want to have to deploy a whole VM image every time you want to rotate the secret ID. So instead, something else like a configuration management system like Chef actually pushes out new secret IDs periodically. It really depends upon your needs. And then once your application has its hands on a role ID and a secret ID, it can authenticate and fetch secrets. Which brings us to part 2, how do we get the secrets into the application memory? So you could modify your application to talk to Vault using a login token or using the app role ID and secret ID, but realistically, most applications are probably not going to be modified that way, even if you do have the source code and can modify them. So there's a bunch of helpers out there, some of them provided by HashiCorp, and we're going to talk about 3 of those: Vault Agent, Consul Template, and Env Consul. The first 2, Env Consul and Consul Template, are unfortunately named. Originally, they were used just for querying Consul, but then they added Vault support. So Env Consul fetches secrets from Vault and puts them into environment variables, and then runs your application as a subprocess so it can consume the secrets from the environment variables. Consul Template is going to query Vault, and it's going to put the secrets into config files instead of in environment variables. And it too runs your application as a child process. Both of these don't know how to log in to app role using role ID and secret ID. They actually need a Vault token. So you're either going to need another piece that will do the login, or you're going to need to use option 1, distribute a token, instead of option 2, use app role. They also will notice when secrets change, and they will either restart the application, or in Consul Template's case, it could just signal the application if the application knows to reread its config and secret files upon signal. Then there's Vault Agent. Vault Agent is really just the Vault binary invoked in a particular way, and Agent knows how to log in. So you can configure it to use a variety of authentication methods, including app role, and it will, when provided the right inputs, like a role ID and secret ID, give you a token. It writes the token to a file, but we've already decided we're not going to modify our application to know how to talk to Vault, so we're just going to instead use the agent templating feature, which is new in Vault 1.3, and we basically took the Consul template functionality and embedded it in agent, so it works just the same, using the same templating language and so forth. And you can configure a kill command so that so that Vault Agent will signal your application whenever it renders the template, meaning whenever the secret's changed. But it's not a supervisor, so you're going to have to figure out how to manage the Vault Agent lifecycle either together with your application or as a standalone application that you deploy alongside it. Maybe you'll use Supervisor D or something like that. So to recap, the way that you do secure introduction with app role is you set up an app role with the appropriate policies that you want. You deploy Vault Agent and a role ID alongside your application. You ensure that a secret ID, hopefully with a single use and a short lifespan, is also rolled out to where Vault Agent can get its hands on it. And then Agent is going to authenticate to Vault. Agent will render the secrets as using its templates. It'll signal your applications. And then your application is going to read the render template in order to get its secrets. And then this last part is important because remember a while back we spoke about, when we were talking about principles, detecting unauthorized access. So if the secret ID were intercepted, since you've configured a low or hopefully 1 use for it, that should mean that it won't be usable anymore if someone else used it in order to get a Vault token. So your application, when it sees that there is no secret there because Vault Agent wasn't able to render it, because Vault Agent wasn't able to log in because the secret ID had been used up, you should treat that as a potential security incident. Your application should signal that into your alerting system, and your team should be trained to respond to that as a potential intrusion. So that's basically it. I mentioned earlier that there's another talk from a couple years ago by Jeff Mitchell, which is focused on secure introduction and goes into more depth than this, and is really talking about the model of deploying a token instead of using app role. There's also a few blog posts or Learn entries that talk about how to do this more concretely, using Kubernetes, using AWS, using app role with Terraform and Chef, various options. I was also going to mention that Vault 1.4 is coming out tomorrow, and there is going to be a live stream hosted by Armand Dadger, one of the co-founders and CTO. It will be at 8 p.m. Pacific time, US Pacific, and it will be recorded if you are unable to attend. Thank you very much.
Perfect. Thank you, Nick. Great overview of Vault. And thanks for keeping us to time too. We're getting away there. That's good. Thank you again. So now I'd like to welcome Grant Orchard from HashiCorp again, one of our local SEs here, who's going to talk about terraforming your data center. So Grant, over to you if you'd like.
Wonderful. Thanks, Pete. So yeah, as mentioned, I'm one of the SEs here with HashiCorp, and we just had a great talk. We just had two great, in fact, we've had great talks all afternoon, but a couple that I really wanted to delve into. You know, Lockie, you spoke a lot about the adoption of public cloud and how they've been able to accelerate that through the use with Terraform. Now, not all customers have, I guess, the dubious luxury of being able to say, we're just going to migrate everything into the public cloud. And so they're looking for the ways and means of which they can actually start to apply some of those principles within the four walls of their data center. So what I'd like to ask you to consider as I talk today, and just keep this in the back of your mind, what would it change for you? What would it change for your organization? What would it change for your projects if your own private data center was actually as just as programmable as the public clouds were? Now, there are some pretty good reasons why this is not the case. Now, when you walk into your data center, and I'm going to make an assumption here, right, which is that your data centers look like the same ones that I used to operate within. And for me, whenever I would, you know, sort of walk down the aisles of a data center, the infrastructure was basically like a museum of IT projects from the past. You know, we had, what did we have? We'd have like a filer on one side that was part of the knowledge management system refresh. You know, there was the bright and shiny pure storage array that was brought in because the database performance was not up to scratch and we needed to get those batch jobs running more quickly. You know, the F5s were brought in because we wanted to have multi-data center resiliency for our application traffic. Gosh, I could go through all of these, you know, and VMware probably is one of those core technologies in the data center too. You know, everybody's looking for the benefits of, you know, deeper consolidation and some of the stuff that virtualization would actually bring. And, you know, that's pretty fantastic, but, you know, it creates a lot of unique challenges for us as operations folk and as engineers actually trying to work on these environments. And as a result, what we really see, and you know, again, Lockie sort of called out this idea, right? When we look to the left of that diagram, teams tend to grow up around the skill sets that they're needing to employ. And, you know, with good reason. You know, each one of these actually require you to really have a solid understanding of exactly how to tune this infrastructure to get the absolute best out of it. You're not going to, you know, see the same skills across, you know, what are broad-reaching technologies. And arguably, even when we're talking about people who are working in the networking space, you're not necessarily going to have your Cisco folk looking after your F5 load balancers. You may, right? But it's not necessarily a given. Now, the way this sort of manifests itself into a challenge for us when it comes to actually trying to work in a more dynamic manner is effectively this, right? And if I go to, say, in the beginning, I go to my VMware team and I say, look, I need a virtual machine. They then have to go off and submit tickets down the path to say, hey, I need an IP address. I need to get the appropriate host name. I'm going to talk to security about certificates and, you know, hand off the responsibility to them for configuring certificate revocation lists and all the rest. And by the time all that's happened, a week's passed, and maybe a week isn't so bad overall. But then we start to get into the stuff that is, you know, particularly viewed as, you know, risky, a lot more fragile, and as a result takes us a lot longer and has a lot more sort of structure and control around. And these are typically our networking devices, right? Now,
Grant,
firewall rules.
Sorry to jump in. Do you have slides sharing, or
I do.
I can't see.
I have a big one up on my screen at the moment.
Okay. Sorry, I thought you were leading into it, but sorry to interrupt.
No. Let's just take a look at Zoom.
There you go. So just go into presenter mode.
Come back up now. And we'll present again. All right. My apologies for just talking at a black screen for all that time. All right.
Thanks.
All right. So here we are. Here we are on the screen that I was on, right? And you know, when we start to look across organizations, enterprises, those things like requesting a firewall rule or requesting a load balancer, configuration change, they tend to be operating, you know, less on the scale of days and more on the scale of weeks. And for medium-sized organizations, this may take, you know, 2 or 3 weeks. In some of our larger enterprise customers, we've seen these things taking, you know, up to 3 months to actually occur. So that's a massive, massive time payment. Some of the other challenges that we actually see is that because a lot of these skills are so specialized, they actually get outsourced to managed service providers. And so when we look at something like a load balancer change, I was talking to a customer recently when every single change that they actually wanted to implement was going to cost them $5,000 when they actually reached out to the service provider. So you can imagine if you're going to be instantiating, you know, multiple releases per week, and each one of those is going to consist of, you know, compute, network, and storage changes, that cost, if you were actually able to release at that velocity, would just be almost untenable. So you get the picture here, right? Each step along the way requires specialized skills, specialized people, and even if they're actually employing their own automation, the reality is there's nowhere to sort of hand that off in a smart way. So the ticket itself may only take, you know, 2 minutes, 5 minutes to actually get done, but in practice, it's sitting there in a queue for, who knows, a day, a week, and so we end up with this, you know, sort of compounded problem. So what if then? What if we were able to swap it out and say, look, the thing that we're actually going to go for here is a removal of tickets. And again, Lockie sort of talked about this a little bit earlier. He talked about being able to use pull requests. I'm going to talk about API contracts, but conceptually we're talking towards the same thing, which is how do we get away from heavily human processes and heavily manual processes and move things, you know, forward in a state whereby a lot of this requesting is actually offloaded, so that rather than, as I said, human processes, we're actually starting to look more at machine-to-machine communications and machine-to-machine systems to actually handle what all this looks like. So that's a great nirvana to get to, right? But if we were to phrase this in a slightly different way, how do we actually deliver a standard means of interfacing with all this disparate infrastructure? And as you'll guess, you know, one of our products is completely built off this entire premise. Now, with over 200 providers and counting, we see a lot of focus going and a lot of attention, rightly so, going into what we can do in the public cloud. The cool thing is that a lot of the lessons that people are learning, the lessons around how to actually move more quickly, how to remove those process blockages, are actually now starting to flow back towards on-premises. And while I'm definitely saying this is a problem that we can solve with technology, the reality is that at its heart, it's not actually a technical problem. It is very much about the operating model and about just how much you're actually willing to change yourselves in order to see these benefits realized. So if we can implement Terraform as a starting point as a technical solution to providing a consistent API contract between all of our infrastructure, then we've managed to unblock one of those major challenges with working and automating within our data center. So then we move on to the second problem. And this is Lockie's slide, right? This is Lockie's diagram. And if we look over on our left and we talk about traditional IT, let's talk about an on-premises or more static operational model, right? We've already identified that the technology is not necessarily the problem, but what do we see? Apart from the idea of fiefdoms, and apart from the idea that people are actually, have their own skill sets, what we see is a lack of collaboration and a lack of ability to work in smarter ways with each other. As we move to more towards this hybrid IT model, we're starting to see some skill sharing, right? Team boundaries are being broken down, but I think what becomes more important in this model is the idea of it's no longer somebody else's problem. And when we start to see teams working together, what it starts to do is get away from some of those more boutique ways of actually automating solutions in place. So if I look across this example, right, virtualization is a good place to start. A lot of people do their automation in that place by leveraging, Power CLI or PowerShell because they've come from that Windows background. Networking teams may, do things like, TMUX or multiplexing terminal connections so that they can operate with multiple devices at once. Storage teams, they're probably still a little bit backwards and maybe using something like Perl, right? But bringing these teams together helps them to start standardizing and start sharing that information. And to be honest, it really is that sharing of information and skills that is the main blocker. Now, unfortunately, we don't live in the matrix, right? It's not as simple as just saying, right, what we're going to do is take the skills of our network engineers and hand those over to, it's like the Linux team. We're not going to be able to transfer all the knowledge and experience and, the paranoia of our security teams and just inject those into the team that are responsible for managing our load balancers. And so the question becomes, how do we actually go about scaling the expertise of our specialists? How do we take that knowledge that's actually in their heads and make that available to everybody? So then that capability can actually roll out across your organization. And, again, Lockie, you've stolen my thunder significantly, and we're going to have a talk about this after the fact. But in seriousness, it all comes down to this idea of how can we actually use something like modules and the private module registry within Terraform Enterprise to take some of those capabilities and some of that specialist knowledge and allow other people to actually consume those. So what I'm going to do now is actually just jump in and show you guys a little bit of what this actually looks like and a little bit of how you could actually take advantage of this within your own environment. All right, let's just hide a few of these meeting controls. Brilliant. All right. So this UI that I'm in at the moment is the UI that you get from Terraform Enterprise. And the majority of the work that you would typically do leveraging infrastructure as code is going to be within an IDE, right? Because ClickOps isn't scalable. It doesn't particularly work that well at speed. But for the sake of showing you what this potentially starts to look like, I just wanted to give you this, this small tour. Now, when we actually go about building these out, let's come in here. The idea that goes into a module is really that it's purely just Terraform code, right? So any of this that you're actually seeing on screen at the moment, and in fact, this is a fairly handy and timely example. So the session that we just had, we were talking about things like Vault configuration. we were talking about, the mechanisms that you need to perform in order to configure things like app role and how you'd actually go about injecting secrets into machines. So here's an example of module code, basically, that would allow you to communicate with Vault to actually create a PKI cert on the back end. Now, realistically, there's probably not going to be a lot of people in your organization who are going to understand what the prerequisites are to configure this. So your role then is to come in and say, all right, I'm going to actually configure all of this for you so that you just need to provide me with, a number of minimal inputs to make this really easy. So do you then need to understand the intricacies of app role? Well, you as the creator do, but the consumers don't. So you're going to go ahead, you're going to create the backend role for app role. You're going to create an associated secret ID. We're going to put a wrapping TTL on it so that you can actually pass back a wrapped response. And then we're going to use the template file function of Terraform to actually go ahead and render this Vault configuration for us. And it's going to pass through then a bunch of values, including some of the information about that app role that you actually created. If we take a look at the configuration file that's here in question, you can see here we're just transposing or transforming some of those variables and updating those. This is basically that configuration file that we just went through. And what this means then is that your knowledge and expertise about how to go about creating a certificate, about how to actually set up dynamic rotation and use auto authentication is actually being passed on to the users without them actually needing to know a great deal of what's going on at all. So nothing particularly clever there in terms of the code. Any outputs that you want to share, you would just declare those in exactly the same way as you would standardized Terraform code. All right, now that module doesn't actually exist here. So let's see whether or not I've actually managed to successfully push that through. Where are we? I'm just going to do a little bit of copy paste here because I can't type and talk at the same time. Modules. All right, so this is as simple as it actually becomes to actually add a module to Terraform Enterprise for you to actually consume. Some simple instructions. And if I hadn't been lazy with my README, you'd actually see a lot more information here to explain to you how you'd actually go about leveraging this. We can see here what the mandatory inputs are, and then other things such as optional inputs that have kind of had some defaults actually set to make life again a little bit easier. Now, again, when it comes to actually teaching people how to consume this, you can really get them started quite quickly within our configuration designer. And what that allows them to do is come in here and say, all right, so if I'm going to be provisioning workloads and I need to actually manage some stuff in here, what have I got? I've got the option to add myself a virtual server on the F5. I've got the ability to come in and add a module for my certificate request that we just saw. And yeah, for DDI, for IP address management and domain management, then we've got info blocks capabilities here. So I'm going to add that module. Basically, you can just throw in all the modules that you actually want to see. And what you're going to get on the next page then is the ability to run through and put in the values that you want. Now, in the real world use cases here, you're probably going to do a bit of deferring, right? Because as an example, I'm going to wait until I've got the IP address back from my info block server before I actually go ahead and create the pool or the node objects within my F5 virtual server. But this gives you then a great deal of sort of capability there. So let's just quickly go through and you'll see what you actually end up with. Configure, what have we got here required? I'll just defer that as well. And we can preview the configuration here and you can see the items that I deferred come up saying, hey, we need to declare these variables. But underneath then come through the modules with a few of those very simple values again to really kickstart the idea of that deployment. And again, as I said, to take advantage of all of the intricacies of the configuration of these elements. Now, if I was to actually come in and take a look at this example. Thought I had that one open, my bad. I've closed all of my modules. All right, let's just, where are we? Terraform dash F5, no. Module dash F5 virtual server. All right, that's a little bit better. Let's maximize that to make it a bit easier and a bit larger. All right, so as you can see, there's a lot more information here. And look, to be honest, I'm only even taking advantage of a small number of those capabilities that are actually available within the F5. But each of these items then you can bring through all the specific configuration and again, start to really look at how you can actually scale this. Some of the smarts that you'll need to bring in and that you can bring your Terraform expertise to are things like how do we actually handle multiple objects. If I'm creating a pull attachment, then I need to create one for each of my nodes. So we're going to have to do things like looking at the count of the IP addresses that you're actually bringing through. When it comes to the node itself, then again, I'm actually reading that through from the node object, grabbing the count index, and in this case, we're actually dropping a specific port on, but you'd probably want to actually turn that into a variable more likely. So all of this, and then any of the additional capabilities of the F5 you could drop into the module. And that is really where we actually get the scale. And this is how we're actually able to take those learnings, take the expertise of your teams, and turn things like what has been traditionally really static infrastructure into stuff that is a lot more flexible and a lot more capable, a lot more programmable in order to speed up the delivery of applications and projects. All right, Pete, I will hand that back over there. I think we're on time.
Yeah, thank you, Grant. Great demo of Terraform Enterprise there. Thank you again. Now I'd like to welcome our last speaker of the day, Jasmine Dahalig from HashiCorp as well, who's going to talk about modern scheduling for modern applications with Nomad. So over to you, Jasmine, if you're ready. Thank you.
Hi, thanks. Let me share my screen really quick before we get started. All right, everyone can see that all right?
Yep, looks good.
Excellent. Hello, everyone. My name is Jasmine Dahilig. I'm an engineer, software engineer on the Nomad team, and I'm here to tell you about Nomad, modern scheduling for modern applications. So if you're here today watching HashiCorp VirtualDays, then you're pretty familiar probably with the problem of multi-cloud and deploying all of your containers or virtual machines, basically moving your applications from cloud, from your pets instances that you manage yourself, to provisioning it on the cloud for really efficient infrastructure. And you're probably familiar with, or if you're here, you've learned a little bit about Consul, Vault, and Terraform, but today we're going to talk, or right now we're going to be talking about Nomad, how you actually run those applications that are connected on the cloud. So the need for a modern orchestrator. When you find yourself moving to containers and clouds, that got really bright, you're going to be migrating your legacy applications from your on-prem instances, maybe to the cloud, maybe some of them are staying in your data center cluster, and you have to kind of deploy it all and migrate these applications over time. But if you've done this before, you know that it's not like a 1-month project. It could be a few months, it could be weeks, it could be, in some cases, I know, a few years if you choose the wrong infrastructure. Or what I'm saying is, if you choose a tooling methodology, perhaps a platform that doesn't really fit well with your existing legacy applications, it can take a lot of work, a lot of configuration, and a lot of hand-holding or managing that you wanted to avoid in the first place with your pet instances. And so when you get to this point where you need to containerize all your apps and you need to move it to the cloud or move it to your on-prem data centers, the question that you find yourself asking is how? How do we do this quickly, efficiently, and easily? And some challenges here are like lack of time, budget, really increased complexity. You have to operate a ton of different instances just to maybe manage your cluster and to deploy them, and then not including your actual applications themselves. So with Nomad, we try to bring you a solution, one workload orchestrator that allows you to orchestrate any type of application on various different infrastructures. A single orchestrator for the cloud. So what we want to introduce with Nomad is a way to run your Windows VMs, your Docker containers, your Java jars, any application binary on any cloud infrastructure, including especially your on-prem data center. So I'm going to go in really quickly, talk about how to use Nomad. It's a very simple workflow. You have your users, which are your devs or your operators, and they have jobs that they need to submit, applications that they need to run, web applications, load balancers, log shippers, anything you could think of, and deploy it to the Nomad server. When you send it to the server, it quickly evaluates the state of the cluster and decides, okay, which of these client nodes am I going to deploy the job to? And here's a sample Nomad job config. Don't worry about it too much. If you're familiar with Terraform, Vault, or Consul, it uses the same HCL format. You can also submit it with JSON. Don't worry about this too much because we'll go over it in depth in a bit. So first, before I get into what jobs are you running, I need to talk about the ontology a little bit. So a job is what you can think of as like a typical like application stack. Like maybe you have like your main application, and then you have like your web proxy, and perhaps a log shipper, and a bunch of different apps that together put together your full application service. Now a task, a group within a job is a series of tasks that are going to be co-located onto a particular client node. And the client node is where the work is actually done. It's where the container or the executable or the jar is actually run. And the task, you can have multiple tasks within a group. So several tasks co-located on the same client node. And a task is like one-to-one with the actual workload that's being executed, such as the container or a jar, etc. And you can run different type of scheduling of workloads. You could have a batch scheduler, which kind of does short-lived workloads for ephemeral reports, transactions, or you could have a service scheduler, which will run long-standing service applications. And then there's also the system type jobs that are for to be run on every single node in your cluster to perform logging, monitoring, security, or other types of background processes. So running any type of workload on the cluster means that there have to be different task drivers on the client node. So the client node, again, is where the workload is actually being executed. But how does it know to run? So we have, for example, the Docker task driver, which will be configured onto a client node. It knows to run Docker. It knows how to download the container from the Docker registry. Or you can have different types of task drivers that just run a raw exec binary or like a jar or a virtual machine in particular. That's one of Nomad's strengths. Different types of ways to deploy your jobs. You can do rolling updates or blue-green deploys for really efficient, high availability deployment strategies. So there's no downtime and you don't have to configure that kind of deployment, like checking if it's okay, and then, you know, keeping this one alive and then rolling it down. Nomad takes care of all of that for you automatically. So operating Nomad architecture is, we will try to make it easy on our operators and on our users, which means a single binary to submit, schedule, and execute workloads. So it's the same binary that you have for the Nomad servers and the Nomad clients. Nomad servers form the control plane for scheduling. They have an assessment of like what all the client nodes, how much capacity they have and what jobs are currently running on them. And you could have a number of server nodes that all communicate through the Raft consensus protocol. And the clients actually have the task drivers on the machines to be able to execute the work. So the clients talk to the servers. This is an example of what a single region would look like. And now for the demo. So first thing I have going on is an AWS cluster of Nomad or AWS EC2 instances. That is my Nomad cluster. So what I have here, Nomad server members. I have one Nomad member or one Nomad server that's running, node status, and 3 client nodes. So the server is, again, what's doing the scheduling. It has an understanding of how busy the whole cluster is. And then the nodes are what actually are doing the work. So here I have 3 nodes, client nodes that are ready to accept work. So break to the demo. First thing we're going to do is look at our simple, very simple example job that can be generated by Nomad just for you to get started and see like what's happening. So so here we have a sample job generated that's just a very simple Redis server. It uses the Docker driver. I believe the Docker driver is automatically included in the Nomad configuration for every client. It specifies the image, and then it maps the port, which if you're familiar with Redis, that's like the default port. And it specifies the resources, CPU, memory, of which I've very much put less than my micro instances in AWS. And then it has this network bit, which we're not going to explain yet, save for later. So Nomad run. And I'm going to go to the website so we can see what's happening. Don't worry about this yet. We'll get to in a sec. So run the job, example. So this little progress bar that's happening here, first, before the Nomad runs the job, before the Nomad client runs the job, it has to download the container, and then it's ready to be run, and it's running. And this is the UI. You could also do like Nomad job status, example, see the full thing, and then dive into a little bit later. You can see the deployment was completed successfully. And now you could zoom in. So going back to the Nomad ontology, we have the deployment here, which completed successfully. Then we have the task group, which is the cache task group. You can see the memory allocation, zoom in a little bit, see the allocations of it. So the Nomad term allocation correspond one-to-one with task group. An allocation is an instance of a group of nodes that are all co-located on one client. So you could have multiple of these allocations for the same task group if you want to deploy them to different clients, which I'll show in a second. Click into that, and then you could actually see instance of all the tasks that are actually running. If you click further, you could see a little bit of the resource utilization information, events that Nomad has observed has happened, and you could also introspect into your tasks by looking at the logs, Redis, and the file system. So now going back to the jobs page, I want to go over a little bit more about deployments. I talked a little bit about rolling deployments, blue-green deployment strategies. So if we go back to this example, then we can change the count in the task group. And also bump the memory just a little bit, just enough to be scheduled on the micro instances. And we could see what will happen with Nomad plan. So Nomad plan is very similar to Terraform plan. It will give you an idea of all the changes that are going to be happening. It's going to create 2 and ignore one, and then it will force create and update the one that's already existing. So let's run it. We could see it happen in real time. So over here, you see the progress bar, there's stuff happening. So it's place 2, and its desired is 3. So it can be kind of confusing to see, you know, you see like, oh, there's more than the actual count that I desired. Well, that's because it's doing a rolling deploy. It spins up an instance, make sure that it's healthy first, and then it'll roll back the existing instances until the deployment completed successfully. And really quick, I'm going to go over another demo. So another simple thing that you may want to do is deploy a web server with a load balancer. And here we have a group, similar thing, place 3 instances of this task group, which will be 3 allocations, so 1 for each node. This one is also using a Docker driver with the HTTPD Apache. And it uses a Consul service stanza. So that's one thing that's really excellent about Nomad, is that it integrates with Consul and Vault out of the box. And it's already running for us to see. And oh, I also forgot to show the Fabio one. So the Fabio one here, we have the Fabio Docker image, and then we have these ports in the resource network stanza. So the web server is running, Fabio's running, and then we can see, oh, no. We could see Fabio if we go to 998, and then we could see the web server, which is routed by 999. So wrapping up the presentation really quickly, Nomad is doing a lot of excellent new features, or it has a lot of existing features. Not enough time to talk about the scheduling process, but it does have native integration with Vault and Consul. This is an example of a Vault stanza, so where you could do secrets management with Vault in Nomad, your Nomad jobs. And you could also do service discovery, which will allow services to find each other, and health check, monitor all applications, which also works with deployments, rolling things back if it's not healthy. And our native Consul Connect integration for sidecar proxies for applications. We have a lot of ecosystem integrations, including a few monitoring integrations. And especially I want to highlight our device plugin extensibility. So if you wanted like our existing plugin, GPU plugin for NVIDIA GPUs, and you want to do like machine learning applications, like you can do that with Nomad. And our team has been really active as of late. So we're releasing Nomad 11 general release, or general GA this week. And it comes with a lot of great features, such as task dependencies, which will allow you to specify interdependent applications and specify a level of granularity between your tasks and even inter-job tasks. Container storage interface, so we're going a step beyond host volumes and implementing CSI for Nomad, allowing you to use any storage provider of choice. Auto scaling is a hot topic, being able to dynamically scale your application instances in a lot of different ways, adjusting the, excuse me. And also the remote exec UI, which allows you to execute commands in the allocations through the Nomad UI for faster operability. And last but not least, can't forget our enterprise. We recently implemented audit logging, which is really important for security, governance, and policy if you want to be able to know what's going on in all of your clusters for auditing. There you go. So thanks for watching. If you want to get started with Nomad, there's the project website, which has our docs. I highly recommend the Learn guides. The Fabio example is there to quickly get you started with Nomad. And also, if you'd like to contribute, we have the GitHub repo. Thank you.
Great, thanks, Jasmine. Great demo. I hope everyone enjoyed learning a bit more about Nomad. Well, folks, that brings us to the end of our Virtual Days webinar. Thanks again to everyone for joining. I hope you got a lot out of it. A big thanks to our speakers as well for today for putting the time and putting their presentations together. I hope you guys got a lot out of it. Some great presentations and demos there. As I mentioned earlier, Virtual Days has been recorded, so we'll make the recording available on the website soon, and I'll send an email to everyone in the next couple of days with a link to that recording. As Jasmine was mentioned about the learning site, if you would like to learn more about any of the products discussed today, I'd encourage you to visit our Learn site, which features some free self-service lessons about each of our tools. And you can find the site at learn.hashicorp.com. So thanks again. I hope you all enjoyed Virtual Days and got a better understanding of how HashiCorp can help you automate, accelerate your cloud migration journey across dynamic infrastructure. So have a great afternoon, everyone, or a great evening if you're in the evening. Stay safe out there, and bye for now. Thanks again.